Kia ora and welcome to this video on question 1 of the 2020 School Calc exam. There are 3 parts to this. The first 2 parts are very short, and then part 1C is a quite difficult equation involving lots of algebraic arrangements, rearranging, substitution, and all that sort of good stuff. Alrighty, question 1A is a limit question. What you can do is type this function into your graphics calculator and have a look at what happens when x gets really, really large. So if you want, put in 100,000 and you'll see that the function's tending towards 0.6, which is a horizontal asymptote on the graph. A real quick way of doing this, just type if we divide everything top and bottom by x squared, the first term will just be 3. This will be 2 over x minus 4 over x squared, and then the denominator 5 plus 8 over x minus 1 over x squared. As x goes to infinity, it's sufficient to say that the 2 over x minus 4 over x squared, 8 over x, and minus 1 over x squared terms all tend to 0. As x gets really large, the numerator is a constant. These things here, we can say that they tend off to 0, and therefore the limit as x approaches infinity is 3/5. Another way of approaching this problem is to look at L'Hopital's rule. There's a French guy called L'Hopital who found out that if you have a function, a limit that you're trying to find for that function that is indeterminate, and what that means is if the limit equals infinity over infinity or 0 over 0, something like that, and this one does, because if we substitute x, well, we can't sub in infinity, but if we sub in a really large number, it's essentially infinity over infinity, then the limit that we want, the limit of f over g, will be the limit of f dash over g dash. So this L'Hopital dude found out that this works. So I could differentiate the top and bottom and get 6x plus 2 over 10x plus 8. And this works if the original limit is indeterminate. If I sub an infinity into here, I'm still going to get infinity over infinity. So I do the process again, diff the top, diff the bottom, and voila, there is, to use L'Hopital's language, 6 over 10, which is 3/5. But of course, L'Hopital's rule is not expected of an NCA level 3 student. Okay, let's just take that to one side. Part B. Part B is a fairly standard integration by substitution, integrating between 0 and a x cubed over square root a to the 4 plus x to the 4, and because the denominator has 2 terms underneath the square root, we're going to let u equal a to the 4 plus x to the 4. When we make a substitution, we always differentiate it. Be careful, we're differentiating with respect to x, so we have 4x cubed, and I'm going to be sneaky here. I'm going to chuck a 4 in there and pull it out again as a quarter. That enables me to replace the 4x cubed dx straight away with du. So I've got a quarter integral du, and I've got 1 over square root u, and I just want to change the limits as well. When x is equal to 0, u is equal to a to the 4, x is equal to a, u is equal to 2a to the 4. Now at this stage, please don't integrate this as log of something. It gets really exciting when you see a 1 over, you think you're doing logs, but 1 over root u is u to the minus a half. If we increase that power, u to the half divided by half is the same as times n by 2. We've got a quarter still in the front there. A quarter of 2 is a half. U to the half is square root u. We sub in those limits. Half square root 2a to the 4 minus square root a to the 4. Root a to the 4 is a squared. So we've got a half root 2a squared minus a squared, which is a squared over 2 root 2 minus 1 if we factor out the a squared. So that's the answer to that question, not too bad. You could make up a value of a. You could make a like 3, chuck it into the definite integral part of your calculator. If you hit the option button, and go calculus, there's an integral symbol. If you typed in x cubed divided by square root, choose a value of a, maybe 3, you can integrate it between 0 and 3, and check that your answer that you get conforms with the answer we've just found when a is equal to 3. It's a nice way of checking. Okay, part C. All of these formulas here, believe off the top of my head they're called Vieta's formulas. Vieta's formulae or equations. This one here is the sum of the roots. This one here is the product of the roots. Then I'd call these ones paired products and triple products. Can easily be memorized. The question's asking us to show it though, so we do need to do a little bit of work to prove this. And then we'll use these in the next question. Okay, so if I take the quartic equation, part C, first thing I want to do, divide the whole thing through by a. I don't set a is equal to 1 because a can be anything, but dividing it through by a means that the leading coefficient there is a 1. Now we were given 4 roots. We said the roots of this quartic alpha, beta, gamma, or upside down fish and delta. And so the factor theorem allows us to factor this quartic. If we know the roots, the factors are the opposite sign. And then if we expand this out, but rather than expanding it by doing 2 brackets, then doing a 3rd bracket, then doing a 4th bracket, we just be clever about it and go, how can I get an x to the 4? The only way I can get it is to go x times x times x times x. How can I get an x cubed? I can go x times x times x times number. And there are 4 different ways of doing that depending on which 3 x's I take. So x times x times x times negative delta, or x times negative gamma times x. And every one of those there's a negative, and then there's one of the 4 roots with an x cubed. Okay, and that's going to be this term here. The squared term, x times number times number. So I'm going x number, or I'm going x number, x number, x number x, or number x, number x, number x, number x, number. There are 6 different ways of getting an x squared out of this expansion. each of them have the two numbers, so a paired product. So I've got to write down all the paired products, alpha beta, alpha gamma, alpha delta, plus beta gamma, plus beta delta, plus gamma delta, all times x squared. And it's positive because I'm going x times negative delta times negative gamma. So two negatives in there. And that gives me this term. Running out of colours. The linear term is just 1x and 3 numbers. And it's a minus because of an odd number of negatives. So I've got minus the triple products, alpha, beta, gamma, alpha, beta, delta, which turned out to be sigma. My Greek alphabet isn't too good. Alpha, gamma, delta, beta, gamma, delta, the 4 triple products, all times x. And that gives us that term. Because remember, the quartic equation we've got, we know the roots of it. So we know its expanded format, we know its factored format, and we can re-expand the factored format, and they're all the same quartic. Okay, lastly, the product is fortunately an easy one. It's just number, 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 number. So plus alpha, beta, gamma, delta. Alright, and that all equals 0. And that there is our constant term. Alrighty. That is the proof done, because we go back to the problem. Alpha plus beta plus gamma plus delta is minus b over a. Yep. If we take that term there, is going to be the same as that term, just the coefficient. So we've got alpha plus beta plus gamma plus delta equals minus b over a. And I could just say equating coefficients gives the rest. Alrighty, so the last part of this question, we now have a particular quartic equation, and we need to find the value of p and the roots, given that two roots, when we sum them, we get the sum of the other two roots. Okay, x to the 4 minus 8x cubed plus 19x squared. Just make sure I've written this down right, I hate to do the wrong thing, plus 19 plus px plus 2. So if I first up start off with the information from the problem, which is that given alpha plus beta equals gamma plus delta, it doesn't matter which two roots I use for this, but the two roots added, alpha plus beta, is the sum of the other two, and I can use these relationships. So I'm going to call them equation 1, 2, 3 and 4, just so you can refer to this later if you want. So the first thing is the sum of the roots. So here we've got alpha plus beta there, and gamma plus delta is the same. So using equation 1, alpha plus beta plus gamma plus delta, that equals 8. Okay, it's minus b over a, so it's that number there. And these dudes are the same, which means that alpha plus beta must equal 4. Okay, that's our first equation that's going to be useful to us. Using number 2, equation 2, that's the paired products one. Alpha beta plus beta gamma plus gamma delta plus, gosh, what ones have I got there? Gamma plus alpha delta plus beta delta. Is that all the ones I wanted? How many alphas have I got in there? Alpha, I've got 3 of them. Beta, I've got 3 of them. Delta, I've got 3 of them. Gamma, I've got 3 of them. Brilliant. So all of those equal 19. Okay, that was that one. See, I won't go yellow. That's that one. Now, if I'm clever about the factorising here, beta times alpha plus... No, so if I'm clever about the factorising, that's not going to be clever. If I look at the last two, have a delta as a common factor, and these two have a gamma as a common factor, and then the other two terms I haven't dealt with, alpha beta plus alpha gamma. And the reason I've done it that way is because we already know that alpha plus beta equals 4. So those dudes are 4. So we've got alpha beta plus alpha gamma plus 4 gamma plus 4 delta equals 19. This is 4 times gamma plus delta. That's also equal to 4 because the sum of two roots is equal to the sum of the other two roots, meaning that this dude must equal 3. 3 plus 4 times 4 equals 19. Yep. So this is a second equation, alpha beta plus alpha gamma equals... Ooh, let me just check this. Was this what I was expecting? No, it wasn't. Something's gone wrong here. Did I have a delta gamma term? Ah, that term there. The last two terms that I didn't factor were these ones. So that needed to be gamma delta. Alright, that's better. I got a bit confused when alpha was in both the terms that were remaining. Okay, so that there is a second equation. Go up to the next page. We've got alpha plus beta equals 4. Which remember is also the same as gamma plus delta. And we've got alpha beta plus gamma delta equals 3. Alrighty, the last equation, I don't want to use equation 3 yet because it's got a p in it, but equation 4 was alpha beta gamma delta equals 2, the product of the roots. Now, what I'm going to do here is let alpha beta equal u, gamma delta equal v. So the first equation tells us u plus v equals 3, and this next equation tells us u times v equals 2. So two numbers are add to 3 and multiply to 2. 1 and 2. So therefore u is equal to 1 and v is equal to 2, or u is equal to 2 and v is equal to 1. Alrighty. Where does that take us? Well, we now know that alpha beta equals 1, because alpha beta is u, and we know alpha plus beta equals 4, or we've got alpha beta equals 2, but alpha beta is still equal to 4. Okay, and solving this, these give us quadratic equations. We've got we could either rearrange one of them and sub it into the other, or just go two roots that add to 4 and multiply to 1 is the same as solving this quadratic equation. Alpha and beta will be the roots of this quadratic equation. So x is equal to 2 plus or minus root 3. So we could just say, like, I don't know, alpha is 2 plus root 3, and beta is equal to 2 minus root 3. It doesn't matter what alpha and beta are, because we just arbitrarily picked alpha and beta. Okay, and then the other one, product of roots is 2, sum of roots is 4. Complete the square on this one. X equals 2 plus or minus root 2, so you know that could be the alpha and beta as well, or it could be the gamma and the delta. The 2 plus root 2, 2 minus root 2. Alrighty, the last thing was to find the value of p, and I could have done that first. You could do it in any order. If I knew the p value, I could solve the quartic on my graphics calculator. But equation 3 is the one we haven't used yet. So let's look back at equation 3. What was it? Triple products. Equation 3 was the triple products, and that equals minus d over a. Okay. So triple products, alpha, beta, gamma, plus alpha, beta, delta, plus beta, gamma, delta, plus alpha, gamma, delta equals minus p. And then I already know the values of alpha, beta, and delta and all that sort of stuff, but I can factor, rather than substituting all 4 of these alpha, beta, gamma, and deltas in, because it's going to be real tedious, I just factor this out. And use the equations I've already got, because I know that gamma plus delta and alpha plus beta is 4 from way back at the start. And alpha beta, if alpha beta equaled 2, then the other one, gamma delta, would have to equal 1. Remember, so I said alpha beta was 2, or alpha beta was 1. It can't be 1 and 2 at the same time, but if alpha beta is 2, then the other roots would multiply to 1. So that gives us 2 times 4 is 8 plus 4 is 12, so p equals minus 12. And like I was saying, if you take this value of p, put it into the quartic, the polynomial solver, and solve the quartic, you should get the 4 roots that we've already found here. Alrighty, catch you in the next video.